Hello everyone, this is Dr. SUMIT CHAUHAN, and today in this video we will discuss about congestion control, which is a part of network layer. This is one of the responsibility that network layer has to take care of. Objective of this video is to discuss the general principles of congestion control, congestion prevention policy, that how to prevent the congestion control in virtual circuit subnets means uh, dedicated connection, and congestion control in datagram subnets. Talking about congestion, an important issue in a packet switch network is congestion. Congestion in a network may occur if the load on the network, the number of packets sent to the network, is greater than the capacity of the network, the number of packets a network can handle. Congestion control refers to the mechanisms and techniques to control the congestion and keep the load below the capacity. Congestion control refers to techniques and mechanisms that can either prevent congestion before it happens or remove congestion after it has happened. In general, we can divide congestion control mechanisms into two broad categories: open loop congestion control, closed loop congestion control. In open loop congestion control, policies are applied to prevent congestion before it happens. In these mechanisms, congestion control is handled by either the source or destination. In open loop congestion control, different policies that can prevent congestion. Retransmission policy has to be taken care of, window policy, acknowledgement policy, discarding policy, and admission policy. Retransmission policy. Retransmission is sometimes unavoidable. If the sender feels that a sent packet is lost or corrupted, the packet needs to be retransmitted. Retransmission may increase congestion in the network. The type of window at the sender may also affect congestion. The selective repeat window is better than the go back N window for congestion control. In the go back N window, when the timer for a packet times out, several packets may be resent. This duplication may make the congestion. In selective repeat window, tries to send the specific packets that have been lost or damaged. The acknowledgement policy imposed by the receiver may also affect congestion. If the receiver does not acknowledge every packet it receives, it may slow down the sender and help prevent congestion. Several approaches are used in this case. A receiver may send an acknowledgement only if it has a packet to be sent or a special timer expires. A receiver may decide to acknowledge only n packet at a time. Sending fewer acknowledgement means imposing less load on network. A good discarding policy by the routers may prevent congestion and at the same time may not harm the integrity of the transmission. For example, in audio transmission, if the policy is to discard less sensitive packets when congestion is likely to happen, the quality of sound is still preserved and congestion is prevented. An admission policy, which is a quality of service mechanism, can also prevent congestion in virtual circuit networks. Switches in a flow first check the resource requirement of a flow before admitting it to the network. A router can deny establishing a virtual circuit connection if there is no congestion in the network or if there is a possibility of future congestion. Closed loop congestion control. Now, this mechanism tries to alleviate congestion after it happens. Several mechanisms have been used by different protocols: back pressure, choke packet, implicit signaling, explicit signaling. Back pressure. The technique of back pressure refers to a congestion control mechanism in which a congested node stops receiving data from the immediate upstream node. It is a node-to-node congestion control that starts with a node and propagates in the opposite direction of data flow to the source. It can be applied only to virtual circuit networks in which each node knows the upstream node from which a flow of data is coming. Choke packet. It is a packet sent by a node to the source to inform it of congestion. Choke packet scheme is a closed loop mechanism where each link is monitored to examine how much utilization is taking place. If the utilization does goes beyond a certain threshold limit, the link goes to a warning and a special packet called choke packet is sent to the source. On receiving the choke packet, the source reduces the traffic in order to avoid congestion. The congestion control in the choke packet scheme can be monitored in the following manner. Each link is monitored to estimate the level of utilization. If the utilization crosses a certain threshold limit, the link goes to a warning state and a choke packet is sent to the source. On receiving the choke packet, the source reduces the transmitting limit to a certain level, say by 50%. If still warning state persists, more choke packets are sent, further reducing the traffic. This continues until the link recovers from the warning state. If no further choke packet is received by the source within a time interval, the traffic is increased gradually so that the system does not go to congestion state again. Implicit signaling. There is no communication between the congested node and the source. The source guesses that there is a congestion somewhere in the network from other symptoms. For example, when a source sends us several packets and there is no acknowledgement for a while, one assumption is that the network is congested. The delay in receiving an acknowledgement is interpreted as congestion in the network. The source should slow down. Explicit signaling. The node that experiences congestion can explicitly send a signal to the source or destination. Explicit signaling is different than choke packet. In a choke packet method, a separate packet is used for this purpose. In an explicit signaling, the signal is included in the packets that carry data. Explicit signaling. Explicit signaling can occur in either the forward or backward direction. Backward signaling, a bit can be set in a packet moving in the direction opposite to the congestion. This bit can warn the source that there is congestion and that it needs to slow down to avoid the discarding of packets. Forward signaling, a bit can be set in a packet moving in the direction of the congestion. Now this bit can warn the destination that there is congestion. Receiver can use acknowledgement policies, slow down the acknowledgement to alleviate the congestion. These are the policies that affect congestion. We have transport layer. On transport layer, we have retransmission policy, out of order caching policy, acknowledgement policy, flow control policy, timeout determination policy. At network layer, we have virtual circuit versus datagram inside the subnet, packet queuing and service policy, packet discard policy, routing algorithm, packet lifetime management. And at data link layer, we have retransmission policy, out of order caching policy, acknowledgement policy, and flow control policy. Thanks for watching. Thanks for watching.